In this session, I am going to explain a linked list, that is single linked list, how it is created and how the elements are inserted. Single list, singly linked list or one-way chain. It is also called as one-way chain. Single linked list can be defined as the collection order of the elements. The number of elements may vary according to need of the program. A node is singly linked list consists of two parts. What are those? One is data part and link part. Data part is nothing but the item which are inserted, and link part is nothing but it is a part which consists of a address of the next node or next variable. Data part of the node store actual information that is to be represented by the node, while the link part of the node stores the address of its immediate successor. This one I have explained in previous slide when the node is created. One-way chain or single linked list can be traversed only in one direction. That is, it can be moved in this way, that is from front to rear. In other words, we can say that each node contains only next pointer. Therefore, we cannot traverse list in the reverse order or reverse direction, because you can see one way is you think it is one node and chain is another node. This chain address is known to the one way, but this chain does not know the address of one way. Therefore, it cannot travels in reverse way, that is from rear to front. Here you can see the example. Consider an example where the marks obtained by students in three subjects are stored in a linked list as in the figure, that is 23, 34 and 90. You can see this is into mark. This into mark is nothing but it is a null value which shows that it is an end of a node, and initially I want to know where I should begin. For that reason, I have taken this node as an head node. Assume that 20, 30, 40 and null. This is an example. If we insert 100, it will be added at the beginning of the linked list. After insertion, the new linked list will be 100, 20, 30, 40 and null. What is the algorithm to implement single linked list? Declare a head pointer and make it as a null, because first a node is taken as an head node to identify where I have begin. Next, create a node with the given data. I will create another node and make the node points to head node, and finally make the node as the head node. That means I have connected that one, and the first node I have made that one as an head. In previous diagram, you have seen how to declare a head node, that is struct node using structure int data struct node and star. Next, this will stores the address of the next variable. Data is nothing but actually what data should be inserted, and next I am declaring that struct node, that is head, that is first node as an head, and initially its value, that is next value, will be always null initially, and this is a self-referential structure. Now create a node with the given data. That means now I am inserting an element into a data part. First you can see void add first struct node head, that is first one, int value, that is now I want to insert a value to the node, struct node. For this, this is a dynamical one. Therefore, I am using a malloc struct node new node, that is I am creating a new node equals to malloc size of struct node. Then for new node I am assigning data equals to values, that means which value I want to insert, that can be done. This is arrow mark can be used during runs. Now make the node point to the head node. For that declaration is same. Now struct node new node malloc, that means I am creating or I am allocating a memory to the add first node function using a dynamic memory. New node I have created, data is added. Next new node new node next equals to head, that means I am creating a new node as an head, that means I am pointing new node to the node. Now what I should do, make the new node as the head node. At first, now I am taking or allocating a memory by using a malloc, that is dynamic memory. Now new node data equals to value, that is value which I want to insert. Next new node next equals to head, I am assigning head 1. Now head equals to new node, that is finally a new node is created which is marked as head. See, this is visual representation, that is head equals to null. Head is initially set to null. Next afterwards I am going to another nodes. You can see diagrammatically 10, that is I have created a, it is 1024. This is the address value of the 10 and this is the null value, that is the head. After this what I am doing, I am adding here 1024, that is the 10 is the item which I have inserted in that a values, and here you can see it is an empty one. Now I have defined that one as an head and I am assigning that one as a null. At last you will see 1024 is the address value of 10 and this node which is consist of null. After this what I am doing, I am inserting an value or address value of the next variable. See here I am taking 20 another new node. Now I want to connect this one. What I am doing, I am taking 2024, this is the address value and I am placing it into a null value. Now you can see that is 20,024. This is sorry, this is 1024 is an where the element is connected. If I see here, this one is add and this is the next node. Here I will go on explaining how it will work. A newly allocated node with data as 10, this one head points to the null. New node next point to the head which is null. So new node next equals to null. Make the head point to the new node. Now the head point will hold the address of the new node which is 1024. This is the new node. Now I am making this one as an head. Finally the new linked list is, you can see here. Now I want to add 30, that is its address value is 3024. Initially this value will be also null. After that I am assigning here. Here what happens, 1024 will assign. See, a newly allocated node data as 20. This one head points to the memory address 1024. This one now 10 is null. That means it is an end of 1. Next new node next points to the head which is 1024. So new node next 1024, that is 10 equals to null. will be added back to the new node. Next, what happens? Make this head point node. Now the head point will hold the address of the new node, which is 1024. This is head point, which will hold the address of this one, and this address is held by year. Finally, the new list you can see here. That is 30 is the value of a head node, and the next, which consists of the address of the 20, and 20 is the value of next node, and in the next what happens, it contains the address value of the 10, and in 10 it consists of null, which indicates that it is an end of the linked list. See, a newly allocated node with data is 30. Next point, head points to the memory address 2024. It has two nodes, 2010, that is null. New node next points to the head, which is 2024, that is address value of the 20. So new node next what happens, it will be 1024 will be added back to the new node. Make the head points to the new node. Now the head will hold the address of the new node, which is, that is 3024. This is the 30 value. Here what is the value is 30, but the address value is 3024. Finally, the new linked list formed. They have been shown. Here you can see what are the functions I have explained before. Same program has been I have written here. First I have declared a node using self-referential structure. Next I am going to add a first node by using dynamic memory. That is, after this I am printing the list. While printing the list, I have taken here as a temporary variable. That is, here from head to last I should move. If I move the head, I cannot come back. For that reason, I have taken temp and I am assigning that one as head, and I am going incrementing the temp. You can see the here, when temp is not equals to null, I am printing that temp of the data. Next temp equals to temp of next. I am moving to the next one. I am printing null value. Here you can see the main function. Initially the head node is assigned as null. I am taking three functions. That is, one function I am inserting 10, next 20, and next 30. After this I am printing the list, that is, which one is head. After all these successful completion, I will return 0 and I will end of the main function. See here how it will begin. Inserting at the beginning, allocate the memory for a new node, store. That means using dynamic memory allocation. Here you can see, that is, I have used malloc, then store the data, change next of new node to point to head, change head to point to recently created node. Here you can see the how it will work. Created a node, I have assigned a what memory. Next for data I am inserting in a 4 as a value. Next I am connecting in address value. Next I am making that one as a head. Now the head has become a new node. Then insert at the end. That means always insert is done at the end. Allocate the memory for a new node. Same procedure. Store data, travels to the last node, change the next last node to the recently created node. I have created that one, that is using new node, and I have allocated memory by using dynamic memory, that is malloc. I am assigned the new node here. You can see same thing 4 here. Next null, I am taking temporary as a head, and I am incrementing temp as a next equals to a new node. Here you can see created. Next, if I want to insert at a middle, what I should do? Allocate the memory and store the data for new node, travels to node just before the required position of a new node, change the next pointer included new node in between. That means here you can see struct node, new node. I am allocated a memory for temp I have taken and I assigned that one as a head. Now int I equals to 2, and this is to identify the position temporarily. I am incrementing all these node. New node of next equals to temp of next, then temp of next equals to the new. Thank you.